Okay, so today we're talking about angled launch. So we're continuing projectile motion. We're going to do symmetrical angles first, and we'll do asymmetric next class. So you have, for a symmetrical angled launch, it's like a flat surface, and you launch something at an angle theta, and it goes up to a certain height, and then it comes down to the exact same level, okay? So your vertical displacement for the whole flight ends up being 0 because it's coming back down to the same point. Horizontal is not 0, okay? So again, these probably you want a little chart, and this chart will be a different one. So we'll do...
Hey, I was just checking in on you. You feeling better?
So in your x direction, your v initial is your v initial times cosine of the theta. Your v final is the same because it's constant velocity. Your acceleration is 0 because it's constant velocity. Your x distance from where you launch to where you end is the range. And the time to go in the x direction is the same as the time to go in the y direction. So these should equal each other. In the y, your v initial is v naught sine theta, and your v final is negative v naught sine theta. So it's the same number in magnitude, but different sign. Your acceleration is negative 9.81. Your x, your displacement, it goes up and it comes right back down to the same spot in the y direction, so that's 0. Why did I put t equals 4? T equals t. Wow. Sorry, I'm crazy. At h, from h till the end, that's what this last column is for, is from h, the highest that it gets to the end. Your v initial at that point is 0, and your v final is still negative v naught sine theta. Your a is still negative 9.81, but now your displacement is negative of the height, and this takes half of the time. Okay, so it's important to note that the launch velocity, so the velocity of the launch at whatever angle theta you have, is equal to the impact velocity at negative theta. Okay, so this velocity, this v naught here, and this theta, and this v here, this is your v impact, and then this theta. So the thetas are the same but opposite, so one is positive and one is negative. And the velocities, the magnitude of the velocities on impact and initial are exactly the same. Okay, what is your maximum range? The maximum range occurs at a 45-degree angle. Okay, at 45 degrees, your v initial in the x direction equals your v initial in the y direction. So that will give you your maximum range. Not maximum height, max range. I'm going to scoot this up a bit. There we go. If your theta is greater than 45 degrees, then that means that your v initial in the y will be greater than your v initial in the x. So that means you will have a higher height. It will go higher. You will have a lower range, and you will have more, it will be in the air for more time. If your angle is less than 45 degrees, then that means your v initial in the x is greater than your v initial in the y, and that will result in less height, less range, and less time in flight. Okay? Okay, now the horizontal portion of this is constant velocity, and the vertical portion is constant negative acceleration. So your horizontal motion graphs are pretty simple. Think of it as constant positive velocity. So if it's constant positive velocity, then your v versus t is just a line with no slope, and it's not accelerating in the horizontal, so your a versus t is right on the 0. Okay? For the vertical component, it goes up and down. And on the way up, it slows down, and on the way down, it speeds up. So you'd have a negative slope going to 0 slope, and then going back into negative. So positive, 0, negative. And then your velocity versus time graph, it starts with a positive velocity, goes to 0, and then to negative velocity. And your acceleration versus time, it's a constant negative 9.81, so it's just a no slope line in the negative quadrant. Okay, so let's do one of these little conceptual practice problems real quick. Okay, so let's look at example 1. Okay, so it says a ball is thrown and follows a parabolic path shown above. Air friction is negligible. Point Q is the highest point on the path. Points P and R are at the exact same height on the ground, above the ground, sorry. And I want to know, how did the speeds of the ball at these 3 points compare? Well, so the speeds are going to be like a vector. It doesn't say if it's X or Y speed, it just says speed. So I'm going to assume that that's the resultant. So at all points P, Q, and R, there's a horizontal vector. So you have a Vx. And as far as velocity, in the vertical, P is going up, so it's going to have an upwards one. Q, its vertical velocity there is 0, so it's not going to have a vector up. And R, its vertical velocity, it's heading down, so it's going to be a negative. So the resultant of this one and this one, they will be the same in magnitude. But this one will be a little less because it doesn't have a velocity vector in either direction, because it's 0 at that point. So these two will have the same speed, and that one will be a little less. So I would say it's D. VQ is less than VP, which is equal to VR. So I would say it's that one. And then which of the following diagrams best shows the direction of the acceleration of the ball at point P? Well, at point P, the acceleration, there's no acceleration in the horizontal because it's going constant velocity. So the acceleration has to be in the vertical only, and that is always pointed downwards. And then it says, which of the following best indicates the direction of net force, if any, on the ball at point Q? Well, I don't think you know this yet, but force is dependent on acceleration, and if the acceleration is pointed downward, then the force is also pointed downward. Okay? All right, so let's do a little practice problem. I just kind of jotted one down. So I guess you can have another piece of paper or something, but here's the one that I jotted down. So you might want to pause it so that you can write it down. So I have a cannon that fires a round at 120 meters per second at 35 degrees across a flat field, and I want to know the max height, the range, and the impact velocity. So first thing I'm going to have to do is make me a chart. Okay. Well, I'm going to actually draw a picture so that you kind of see like what's happening with my picture. I'm going to change pen colors. Maybe. Yes, I am. Okay. So what's happening? So you've got here's your flat field. That's as close as flat as you're going to get from me. I don't draw. And here's your V initial, and it's going to go across the field. So your V initial is 120 meters per second, and your angle theta is 35 degrees, okay? So that's what we know. Now, I can find my V naught in the X. It's just going to be 120 cosine 35. So 98.3 meters per second. And I can find my V initial in the Y. That's just 120 sine theta. Okay, and that's 68.8 meters per second. So now I'm going to make my chart. So I'm going to have an X, a Y, and an H. Okay, and I have a V naught, V, A, delta X, and T. So my V initial in the X was 98.3. So those are both 98.3. My acceleration in the X is 0. I don't know my range. Sorry, and I don't know my time. My V initial in the Y is 68.8. My V final is negative 68.8. My acceleration is negative 9.81. My delta X is 0, and I don't know my time. In the H, for the halfway point and after, my V initial is 0. My V final is negative 68.8. My A is still negative 9.81. And my delta X is my height. That's my max height, so I don't know that. And then this is going to be, this time is going to be half of these two times, right? So remember that this is half of those two. Okay, so first thing I need to do probably is find time. So I can use the acceleration formula for either the Y or the half Y and find the time, okay? So I'm going to go ahead and use the half Y because I need to find max height first anyway. So I'm going to start with A. I'm going to use the H values. So if A equals V final minus V initial over time, then time equals V final minus V initial over acceleration. My V initial here is 0. So then my time for just the halfway point, okay, just for point H and beyond, is negative 68.8 divided by negative 9.81. Okay, and I get about 7.01 seconds. Okay, so now I can actually find my Y value, delta Y, right, for my height. So my delta Y is V naught T plus AT squared over 2. My V naught here for the H value is 0. So that's just negative 9.81 times 7.01 squared over 2. Okay, and I get negative 241 meters. So this is the max height. Now I know it's negative, so just don't box the negative. You know what? Where is my whiteout? There we go. I should not have boxed the negative. I've already told you guys, don't box the negative, and I just did that. Okay, so it is, you do get a negative because it's falling down for the, after the H, like here's the H, right? This is H. From H to beyond, it is going down, so you have a negative value, but because I'm asking for max height, just don't box the negative, and that's your max height. Okay, so max height has to be a positive number, okay? Okay, so that's part A. And now that I know my time for the half, right, I can actually put that in my chart if I want to. So that's 7.01. So these two are double that. So this is 14.02, and this is 14.02, okay? So now I know my times for these, so now, and I found my height, and so now I just have to find my range. So, so for part B, I can use just my X data. And so my range, I can think of it as like delta X equals V naught T plus AT squared over 2. But now my acceleration is 0, so this whole thing just factors out. So then my displacement is just V naught times time, which is 98.3 times 14.02. So I get about 1378 meters, and that is my range. And then for part C, it wants to know what's my impact velocity. Well, that's pretty simple because this is angled launch. So my initial was 120 at 35 degrees, so my impact has to be 120 meters per second at negative 35 degrees. And that's it. Okay, so there's one full example problem done and notes, and you should be set until I see you again. Bye-bye.